Okay, this is the pretest for Unit 5, and it deals with the exponent laws and deals with evaluating expressions. And so over here on the right-hand side, we have all the exponent laws that we'll be referring to as we work through these exercises and try to remind you of how these fundamental exponent laws work. The first one gives you x to the second times x. And of course, you have to remember that x has an exponent on it of 1. And so we're applying that first exponent law, x to the a times x to the b equals x to the a plus b. And so as a result, we get x to the third, which is probably pretty obvious and pretty well known. Now the second exercise here to evaluate x to the fifth over x to the fifth, note x cannot be 0 because you can't divide by 0, and so we disallow that. That's what this caveat is for here. And pretty obviously the answer here is 1, because anything divided by itself is going to be a 1. Now, if you also look at it from the point of view of the exponent laws, what you have here is the second exponent law, x to the a divided by x to the b, and the rule says that you subtract the exponent. So that's 5 minus 5. And of course that gives you x to the 0 power. So it must be that anything except 0 to the 0 power is a 1. We have an equivalence there. Um, and so that little exponent law is delineated right here. Anything to the 0 power is 1, um, except 0. You can't have 0 to the 0 power. That's an undefined situation. Um, the next rule, x to the third divided by x to the sixth, demonstrates another one of our exponent laws. And of course, one way to look at this is just by pure definition. You're looking at x times x times x divided by 6x's multiplied together. And then because multiplication and division are inverse operations, we can cancel the x's. And so that leaves us with a 1 in the numerator. And downstairs we have x to the third. Now, the other way to think of this is use exponent rule number 2. And so if we do it that way, we get x to the 3 minus 6. It's the numerator's exponent um, minus the denominator's exponent. And of course, that gives us x to the minus 3. Well, again, we have an equivalence right here. X to the minus 3 power is equivalent to 1 over x to the third power. Um, and so we're demonstrating that with this x to the negative a equals 1 over x to the a in our exponent laws. And so that says you can change the sign of the exponent by merely moving it from numerator to denominator or vice versa. You don't have to change the sign of the base at all, notice. Just the sign of the exponent changes. And so for question number 3, you might have had two answers. You might have had x to the minus 3, or you might have had 1 over x to the third. The preferred answer is really the one that has a positive exponent. Try to keep exponents positive whenever you can. Now, question number 4, this evaluating this expression, deals with a fractional exponent. And oftentimes students will have trouble with fractional exponents. So let's remind you a little bit about what that's all about. When you have a fractional exponent, the numerator of that exponent is the power, and the denominator of that exponent is the root. And we've shown that over here in this last exponent law. X to the a over b power is the bth root of x to the a, or you can write it as the bth root of x to the a, because the power and the root are at the same level in terms of order of operation. So it doesn't matter which one you do first. Typically people do the root first when working with an actual number because it makes the number smaller, and then they raise that smaller number to a power. So in this case, 16/27 to the 3/2 power means the square root of of 16/27 cubed. Right? Well, of course, the square root of 16 is 4. And we're going to leave the square root of 27 just as it is. We could simplify it, of course, but for the time being, we'll leave it just like it is. And now to cube this thing, in other words, we did the root first, and now we're going to go ahead and do the power. It's going to be 4 over square root of 27 times 4 over square root of 27 times 4 over square root of 27. And of course, that gives you 64 in the numerator. And then if you work the denominators a piece at a time, the square root of 27 times the square root of 27 is going to yield a 27 times the square root of 27. And then I'll break down this square root of 27 using a factor tree situation. You should remember from elementary algebra, square root of 27 is the square root of 9 times the square root of 3, and the square root of 9 is 3. So that square root of 27 can be rewritten as 3 square root of 3. And then if we just multiply the 27 times the 3, we get our final answer, 64 over 81 square root of 3. Now, if you want to remove the radical from the denominator, this answer is perfectly acceptable. 64 over 81 square root of 3. You could multiply top and bottom by square root of 3. And you'd have in the numerator now, just write it over here, 64 square root of 3 over the square root of 3 times the square root of 3. Those two numbers together there are going to make a 3. So we'll have 81 times 3. So if you want to rationalize your denominator, it would be 64 square root of 3 over 243. So that answer would be acceptable as well. It's an equivalent answer with a rationalized denominator. So once again, when you have a fractional exponent, the numerator of that exponent is the power. The bottom is the root. Typically, you want to do the root first to make the number smaller, and then apply the power. And it should be pretty good. The next exercise is similar. You're given a fractional exponent again, and it's 27 over 125 to the 2/3 power. And so think about that 2/3 power, and you know the 3 represents a root, right? So what this means to us here is cube root of 27, which you should know, over 125, and then square that. So the cube root of 27 happens to be 3, and the cube root of 125 happens to be 5, and then we have to square that. And when you square something, you multiply it times itself. And so 3/5 times 3/5 is 9 25ths. And that would be your final answer for that question. So fractional exponents, just remember the bottom is going to be your root, and the top is going to be your power. You usually can't get in too much trouble from there. Number 6 at the top of the next column is 2x squared cubed. And of course, to cube something means to multiply it times itself 3 times. And so in this case, we mean 2x squared times 2x squared times 2x squared. And that's going to give us 8x to the 6th. Now, as a shortcut, what we're really doing is the x to the a to the b power. And when you raise a power to a power, you multiply the powers. And so pretty obviously, the x to the 6th is going to happen. What students will commonly forget is that the 2 has an exponent on it as well. The 2 has an exponent of 1, and so that's going to be 2 to the third power times x to the sixth. Now again, this only works over a product. It can't work over a sum. If there was a plus or a minus between the 2 and the x squared, you wouldn't be able to apply this rule. But because it's a product, you can exercise that rule and get your final answer of 8x to the sixth. And we'll use that same idea in question number 7, raising a power to a power on a product. And so here we'd get x to the minus 6 and y to the minus 3. And that would be acceptable, although typically you don't want to leave things with negative exponents. And so we'd use the 1 over rule that we identified earlier. And you would make this 1 over x to the sixth, y to the third. So it changes the sign of the exponents to a positive, which is a preferred look. Now, question 8, we have a fractional exponent. We're back to a fractional exponent there. And we have 1/9 to the negative 1/2 power. Well, again, I'll remind you, the 1 has a 1 on it. 9 has an exponent of 1. And so we're raising powers to a power. And so this could be thought of as 1 to the negative 1/2 power over 9 to the negative 1/2 power. And we just applied this exponent law right here. We raised a power to a power. Now, because we have a negative exponent and we'd like to make it positive, we're going to move the 1 to the minus 1/2 to the denominator. And correspondingly, the 9 to the minus 1/2 that's in the denominator, we're going to move that to the numerator. And so the expression becomes 9 to the 1/2 power over 1 to the 1/2 power. And what does the fractional exponent mean? Well, the 2 is the root. So we're talking about the square root of 9 over the square root of 1. So it means this, right? Square root of 9, square root of 1. And the square root of 9 is 3. And the square root of 1 is 1. So your final answer on that question number 8 should be a 3. All right. So a fractional exponent and a negative exponent, raising a power to a power, a bunch of exponent rules in that situation. Now, question 9, take a peek at this. We've got x squared over y z cubed raised to the 1/3 power, which gives us x to the 2/3 power. Make sure that makes sense to you. We're raising a power to a power, so we're going to multiply 2 times 1/3. And the 2 can be thought of as 2 over 1. You multiply your numerators, multiply your denominators, and you've got x to the 2/3 power. In the denominator, remember the y has a 1 on it, and 1 times 1/3 is of course 1/3. And 3 times 1/3 is of course a 1. All right. So there's your final answer. The notation would be acceptable just like that. Want to remind you what this 2/3 power means. The 2/3 exponent means again. The 2 is the power. The 3 is the root. And so it's equivalent to the cube root of x squared over the cube root of y times z. And it is, I suppose, noteworthy that it could be written cube root of x squared over cube root of y times z. All right. And so working between the fractional exponents and the radical notation, you want to make sure you're familiar with both of those. The last exercise, x squared plus y to the 3rd power. couple ways you can do this. You could use the binomial theorem to do the expansion from, say, an Algebra 2 class. Or if you prefer, you can, by definition, go x squared plus y times x squared plus y times x squared plus y. Now the first product, if you multiply this pair, that should be pretty easy, and about this time of year you should be able to be doing that maybe right in your head. You're going to get x to the fourth, and of course you're going to get y squared, and then the outer pair and the inner pair is going to get a double of x squared y. So doing those kinds of quick little things can really help in a Calculus 1 class if you don't have to spend extra time thinking about that. So multiplying a quantity, a binomial times itself, should be something you're experienced with. Now we've got to take each term in that thing we just came up with and multiply it times x squared plus y. So when the x squared multiplies through, that's going to give you x to the sixth plus 2x to the fourth y plus x squared y squared plus x to the fourth y. Now I'm multiplying the y through, plus 2 x squared y squared. And I need my eraser. Make myself a little more space here. And then the y times the y squared gives me a y cube. All right. Now there are a few terms that are common. We have a 2x to the fourth and an x to the fourth y, 2x to the fourth y, and a 1x to the fourth y. So we're going to have 3x to the fourth y. And then we have 1x squared y and 2x squared y. So that gives me 3x squared y squared. And then finally, our y cube on the end. All right, so there's our algebraic expression, taking a binomial and raising it to the third power. Could also look up doing it by the binomial expansion. So if you're familiar with your basic exponent laws, this Unit 5 shouldn't pose too much of a problem. We'll put up another video or two in the next couple of days dealing with problems as questions come in and as we analyze the data from the Unit 5 pretest. So if you have questions, please send them in. We'll try to answer them.